hi guys. We're going to move on to our final talk before lunch. So the talk's titled Mastering Data-Centric Engineering, 12 Principles of Success by James Bowkett. James has over 20 years of experience as a lead developer in finance, specializing in data-intensive applications like fraud detection and pricing, primarily using Java. He is passionate about quality software design, advocating for XB practices such as TDD and BDD. As technical delivery director at OpenCredo, James focuses on analyzing, architecting, and delivering pragmatic solutions that bring real business value. He has also presented at various data conferences. So if you could all put your hands together for James.
Thanks. Thanks for that intro. Well, actually, thanks to my marketing department for that intro, actually, because it was a little bit longer than I anticipated. But so the title of the talk is Mastering Data-Centric Applications, 12 Principles for Success. So a little bit about me. I promise I won't spend all the 40 minutes talking about me as well. So as I said, my name's James Bowkett. I'm from OpenCredo. We've got a stand outside. But we're a hands-on software development consultancy. So we help customers deliver more effectively across a range of areas, and kind of the most relevant for this talk is data engineering and platform engineering. And there's a bit of a sticker collection of some of the technologies that we work with there. But my career has mostly been in and around kind of data-centric applications, basically where you draw a tin can in the middle of a diagram, and then you have lots of lines coming off it, and you do some stuff with it. So I was going to start with a straw poll, but I'm not. I'm going to start with an assumption. So this is the obligatory DALL-E-generated slide, and again, with my marketing department, I promised I would mention AI. So I'm going to assume that we all like shiny things, right? So this is, when I talk about shiny things, I'm talking about, data science, decision science, machine learning, ML ops, graphs, databases, dashboards, all of this stuff. This is the kind of stuff that gets us into East London on a wet Saturday morning, right? So thank you for coming down as well. But now, the problem is, I've got a bit of a reality check for you. Because if you want the shiny stuff, I'm afraid you've got to do the boring stuff right. So if maybe you've got a Lambda architecture, remember that? Lambda architecture, or maybe you've got a Kappa architecture, or you've got medallion data structure, or you've got a data lake or a data lake house, or perhaps you're one of the cool kids. I did already hear data mesh mentioned. You've got a data mesh or a data fabric. So all of these kinds of data estates and all of the flavors in between, they've got certain things in common. Now, our stakeholders expect continuous delivery, right? So you want to be able to, in order to do continuous delivery, and that's a challenge with data-centric projects. In order to do that, they need to be deployed quickly, they need to be testable and tested, and you need to be able to upgrade them in a safe and controlled manner. So this is regardless of if you're in a schemaless world or you're in a structured data store world. This is a problem because this is the modern way that stakeholders expect their software to be delivered and developed. So I've borne this in mind. As I said, been in and around kind of data-centric applications for a long part of my career. But then in the recent years, I actually kind of worked with 12-factor apps, and I've realized that changed the world in way in which I think about kind of microservices and how those things are deployed. Now, there's a really nice stat that I pulled off the internet, so it must be true. There's a link at the bottom there. So even if we don't realize it, each internet user is personally generating 1.7 megabytes of data per second. So us sitting here, perhaps you're checking Facebook or Google or Maps or email or whatever it is, you've got adverts in all of that, and you're creating data. You're generating data. You're generating derived amounts of data. So bear that in mind, that we're generating these enormous data estates. Now, bear that in mind for 1 second and keep this other thing in mind. There's a really great quote by an engineer on Twitter, which also means it must be true, is that the problem with quick and dirty is that the dirty remains long after the quick is forgotten. That's a guy called Steve McConnell. But that's really, really interesting. If you keep those two things in mind, it's like, oh, well, I'll just do a little hack here, or I'll just do I'll just rush it into production kind of thing. Oh, don't worry about it. It's just a string. I don't care, you know. Now, the problem is, if the norm is dealing with terabytes, petabytes, zettabytes of data, you know, we're not far off that, right? Those little things that you didn't really pay attention to at the start, or when you could have done and when they're cheap to do, those start to multiply out, and you end up with a bit of a mess on your hands. So this is a little bit of a crusade of mine to make sure that we don't create these data estates which create a rod for our own back. You know, let's fix them while it's cheap and easy to do so, and then get them into production. So much as the 12-factor app kind of changed how we think about kind of cloud-native and server-side architectures, especially in terms of observability and deployment, let's have a set of principles for data-centric applications as well. Because data-heavy applications have always suffered from not really lending themselves to continuous deployment, because they kind of drag this great big data estate with them. And everyone goes, well, if you haven't done a full regression test in prod, I can't trust it. So can you push out that release timescale for 3 months? It's like, well, actually, there's no need to do that. There's ways and means that we can make sure that that's not an issue. So this is a bit of a guide for designing data-centric applications and recommendations for how to approach some of those sort of socio-technical changes of becoming a data-centric organization. Now, I have 4 categories. So I'm a data guy, so there's 12 principles, 4 categories. You would think I would manage to shoehorn 3 in each of those, and I haven't done that, so I very much apologize in advance. It pains me to say that I have, but at least I have 12, at least it's an even number, right? So moving on to the first one, so architecture and design. So the first principle is data structures as code. Please do this. Please do this. If you're using a structured data store or something that actually needs to configure a data platform or something like this, maybe you've got Databricks or you've got SQL Server or something. If you don't do this, you've got no traceability between the data structure that you're using in prod and the application code that relies upon that. They are coupled together. They are coupled together, because it will have certain expectations in the application code. So couple them together with deployment as well. And if you don't have this in code, when you come to roll it out into another environment, you're ending up with a snowflake-style environment where each one is kind of different. And you can also, the problem with that is that can also drive unknown behavior between those environments as well. So the way that your database is set up, whatever that might be, can actually change the way your application behaves as well. So for the sake of your sanity and your fellow humans and things, please don't make manual changes to that, to those data structures ever, because it's quite easy to use. There's all manner of tools that you can use, things like Flyaway or Skitch or Liquibase, even Terraform. Terraform's not great at this, but infrastructure as code applied to data structures. It's easy to do, cheap to do. All you need to do is kind of spin up an ephemeral container, do a migration, and then the container dies, logs the result, and dies. Now, one of the things I also like to do is actually to extend that not just to the data structures, but also to the configuration of those clusters as well. One of the things I like to do is something that's box fresh. I've just installed it. I actually download the config of that data store, stick it straight in source control, because that's what it is, straight out of source control. This is how it behaves. Because when it's in the middle of the night, someone phones up and says, the thing's not working. It's like, oh, okay, do I want to go into the settings and figure out what the settings are and what's happening on this environment, or do I just need to go straight to source control and say, okay, that's a version of the settings. I know it's the same. I can isolate all of those issues. I don't need to worry about that because it will behave in exactly the same way. So moving on. Append-only data structures. So as I mentioned earlier in my 20-minute intro, I'm a finance guy. And we don't have a monopoly on append-only data structures, but it's something that I come across quite a lot in and around finance. And it makes your data estates a lot easier to reason about. If you think of a traditional SQL store, deadlocks are caused from updates happening at the same time as reads. And that is just painful because it all becomes a little bit unpredictable as well. Append only gives you a full history of your data as well. So, I mean, a lot of you folks will be data scientists. And so actually being able to kind of time travel through your data, what did I know last week, last month? Not just how does the data look today, but what did it look like back when I knew that? Because it stops you doing overfitting and all of those kinds of nastiness when you're doing backtesting and things like this. And something to bear in mind, and I find time very difficult to think about, especially in terms of data, but loading data is not the same as business data. So then in your application logic or your aggregation logic, you're actually going to end up with multiple records for a particular business entity, for instance. But if you've got these append-only data structures, you're always leaving a footprint. You know, you're not just updating it and changing it in place. You're leaving a footprint. So what did I know at that time? And that makes debugging a lot easier. So I've got some other principles a little bit later which actually kind of work in concert with this. Because when you kind of want to say, quite often when you get someone said, there's something wrong with this report, and the data is a week old, and some Herbert has then gone and updated that data in place, you go, well, I don't know what it looked like back then, and I'm sorry I can't help you. But actually, if you're doing append-only data structures, you're able to kind of restate that data. And future you will thank today you, I think, if you do that. Moving on. Optimize for access and retrieval. The value from data is not from collecting it and storing it. It really isn't. If it was, we might as well just dig a hole in the ground and just shove the data in there. The value from data is from reports, from analytics, displays, aggregations, models, stuff you're going to do with that data. So the way of storing the data, or the way that the data occurs, and it naturally occurs, is not always the most optimal way to kind of play that back and actually work with that data as well. So disk is mostly cheap, you know, depending on solid state or if you're in the cloud. But maybe denormalize that data that won't change. You know, it's especially true if you're following the last one, which is append-only data structures, you know. So actually you're going to start chewing up data and things like this, but actually it's for a good cause, yeah? Alternatively, you might want to provide, you know, different summary cubes and things like that. I'm kind of talking OLAP cubes and things like that. It's a bit old school, but you know, it still kind of applies. You know, there's, you know, everyone thinks that if it's not new and shiny, it shouldn't be used. But actually, there's a lot of old school, you know, Kimball modeling and stuff like that. It's been around for a long time, and it's actually of very good value. Now, but the problem is there is a bit of a trade-off here. So the trade-off is any bugs in the upstream will then need refixing in any summary cubes that you've created a little bit downstream. But that, you know, that becomes, if you're tracing your lineage, that should be easier to actually kind of unpick and to actually figure out whether that's worth, you know, monitoring and feeding and watering and looking after those cubes. But, you know, some systems, things like Kafka and things, they're optimized for writes, but you need a plan to get to that data. I mean, I love Kafka. But actually, people go, I've got this Kafka estate. Oh, can I just write a query against it? Oh, no, not so much. It's kind of time-ordered, and this is a problem. So actually, you know, optimizing for how you're going to get at that data, maybe you need some kind of temporal summary store, that's something to think about. As well, I would imagine a lot of the folks in this room are maybe using S3 just as a dumping ground for your data. You know, it's cheap and easy, you dump it there, but how are you going to get at it? You know? If you're going to use Athena over the top, that's a really nice way of doing that, but you've got to be careful of the schema as well. You know, how does the schema change over time as well, so that you're actually still able to get hold of that data, even in, you know, 5, 10 years, you know, when we're all old and grey. Older and greyer, sorry. Separating data from logic. Now, this is a bit of a hobby horse of mine, so I want to spend a little bit more time on this. So over the course of my career, I've worked with folks that are quants and data scientists and things like that, and they have a tendency to do this, and it really bugs me. Because, what does that say? if you embed special values into your data, that's a leaky abstraction. And we'll come on to, I'll show you some examples of what I mean by that. But if you've got a special value somewhere in the data, it means that everywhere that accesses that needs to understand what that special value means. And then if you update that special value, or that special value has a new meaning, all of those places need to change as well. So it's leaking out into other places in your estate, right? So here's a naive-looking table. This is roughly an example from something I worked on, actually. I've got two special values here. This was probably from the days of SQL Server 2005, I think. Those were the maximum dates that you could express within that version of SQL Server. But is that a bona fide date? 1753? Is, 9999? Is that a bona fide year? You don't know. See, this is where it's going to start to leak out in everywhere I'm accessing it, yeah? So if I want to get all the current records, do I select where end date is null or end date is December 31st, 9999? Changing these kind of semantics means that someone has to document it, or worse, someone has to talk to somebody. None of us like talking to people. You want to have something expectation. You don't want any surprises in your data estate, right? You want someone to come in and go, oh, right, it's end date is null. That's the current record. Great. I've got another example. So this is kind of a table of kind of contracts. Now, what if columns change their meaning based on the value in another column? This is another sucky place to be as well. So if this is a contracts here, we've got this. This guy here is a breach of contract at the top here, and the other one says it's a breach, but actually it's matured as well. So if I want to know all of the breaches, so that's fine, that's straightforward. But is this for a breach or is it a matured contract? I don't know. I would have to know by having some kind of complex piece of logic to actually interpret this data, rather than it being natural in the actual table itself. So another one, which is kind of a pretty horrible, a pretty egregious example, is reusing columns if they don't actually apply as well. Or basically, so this might be a table of trades. And if you're familiar with finance, and I would imagine there's quite a few people that are familiar with finance in here, table of trades is a good thing and a wise thing to want to generate. But different underlying instruments have different characteristics. So the schema actually changes. If you're an option, you're a derivative of some form. So you have an underlier. Yeah. If you're an equity, you don't have an underlier. That's just the equity itself is the instrument. So here we've got some magic values. Here, option, equity. What if that's spelt wrong? What if it's in capitals? What if it's not? What if that changes over time? What if we then start doing swaptions or something like that? All of the access code needs to understand what these values are, because it's sort of related, or I kind of play fast and loose with the language of this. It's sort of related to kind of strongly typing your data structures. But all of these examples kind of share a kind of a common solution, if you like, is that you're going to end up needing to bake some of that logic into either code or into a view of some description if you're talking relational, or everywhere where that data is queried. If those values change over time, you best hope that you can track the code that generated that data as to what were those valid values at that point. And that's also something that we'll come on to as well. But again, this is all, I'm trying to kind of build a little bit of urgency of like, please don't do this, because you want to make these things a little bit more, someone can pick it up and go, oh, I know what this is, I can work with it. Because as soon as you don't have that, then you're actually kind of making people have to talk, and that drags on people's productivity, and you're getting further and further away from something continuous delivery like. Yeah. Moving on to the next one. Strongly type your data. There we are. You can see it's a Rolls Royce in preparation that I've done here. But being strict with the data that you let in to your data store, it allows you to maintain that data quality. Now, this is really important a little bit later on if I talk about kind of treating data as a product. We don't want surprises in the data. We want it to be sort of, oh, this makes sense. Yeah, its price is a double field or it's an integer field, and it's the same everywhere. Yeah. And this applies to NoSQL stores as well as stores with schemas as well. But so what if you store a number in a string column? You know. Now the problem with that is that sorting will be based on your collation in your database. So that's then based on a piece of database config, which if you haven't stored it in source control, that might be different in your different environments. You see, I'm trying to give you a doomsday scenario with this because some of these kind of do interplay with each other. So the sorting will be based on the collation, and it's another leaky abstraction as well. I've got an example here as well. So say we've got user ID and we've got a string of 5. We've got the Gopher, we've got Duke from Javaland, and a pair of Pythons there. Now everywhere that accesses that data, they've got to do type conversion on it. That's just code that doesn't need to be there. That's technical debt, instantly. Just because someone sort of said, well, I'll just stick it in a string column and that's okay. Yeah? But it has knock-on effects. And you're creating code that doesn't, and code is harder to read than it is to write, you know? So the more clutter we're creating in the code, the more we're slowing people down, the more we're dragging on the application developers' productivity. So that design choice, or lack of design choice, has leaked into all these different code bases, and actually it didn't need to be there. Right, so moving on to the next category. Quality and validation. Architects for regression testability. So this is something that's quite close to my heart as well. So data's getting bigger all the time, you know, so being able to then actually regression test that data and prove the correctness of that data or the new versions of that data is going to be more and more important. And so we're going to get to a point where most of our data estates, we can only test the deltas, the new features coming in. We're not going to be able to do a full regression test suite. You know, I worked for a long time on a risk system, and risk systems take in big wadges of data, and then they do big wadges of calculations to it, and then a week later someone says there was something wrong in that data, and you go, oh God, now I've got to go back all the way through. And I've got to do a 3-month project to actually kind of test this thing. That's what I want to avoid. Now, there are ways and means of doing that. So one of the tips that I wanted to kind of bring to you was, so this was kind of what I was saying, is that actually data files get loaded into prod. Oh, blimey, 10 minutes. Oh, crikey. OK, this is going to go a lot quicker. And then what we'll do is we'll usually do a dump of prod, load it into UAT, and 3 months later, we might say that this is ready to go. Now, if we reset a second, what we could do is we could put an immutable stream. Kafka is a lovely immutable stream. I love Kafka. But you could use Flink. You could use Red Panda as well, which is a cool replacement for that. You could use Pulsar. But if you've got something immutable there, it can't be changed. Yeah? So you could listen into it and pour that data into UAT. It's kind of like a T, like the Unix T feed. But what that means is that UAT is guaranteed as a carbon copy of prod. So we've got that data. So we don't need to wait for somebody else to do us a database backup and load it into UAT. We've already got that data, and we can work on that data. Now, we could then, that starts to open up some really interesting things, like doing blue-green deployments as well. I did a presentation a couple of years back on blue-green in data-centric applications. Thing with blue-green is that you have to then realize that I might have a blue version and a green version of a piece of data. So everything that works on that data would now need to understand that whether I'm in blue mode or green mode. Yeah. But what it means is that you can regression test these data, these new features within UAT, and you can compare prod against UAT. Right. Ooh. last time I presented here, I kicked these lights over, and then I did the rest of the presentation in the darkness as well. So I'm definitely trying not to do this. Well, this is an easy one. Track changes in your test data. Now, if you've been in and around kind of data-centric applications or been a data engineer for any sort of length of time, what generally happens is you're an engineer, someone from an upstream system says, hey, I've got a data feed for you, here's an example file. You go, oh, brilliant. I'll write some code and I'll bake in some test cases into this data and things, and I'll embed it within that data file, and I'll check it in. It's in a unit test. Awesome. 3 weeks later, they say, that data file I gave you was rubbish. Here's a new one. You go, oh, now I've got all these special values that I've embedded in this file, and I don't really know what pertains to what test. And now I've got a new format of the file. So what you can do, nice and easy, as soon as you get that data file, for the example data file, pop that straight in source control. You know, just fresh. It's as it was, as Mother Nature intended. That this is what it looks like today. And then, as you start to build out your test cases and embed them into your code, actually then do a check-in with that. So each thing you say, well, actually, I've got this test case for if it's null, or I don't get an address field in, or I don't like the postcode field, or whatever it might be. Because then what you do, when somebody gives you a new test file, say, well, actually, I know what the deltas were that I applied to that original file, therefore I can just rebake that in and just sort of make those test cases start to pass again on the new data file as well. So this just sort of brings a little bit more robustness into the applications that you're writing in and around kind of ETL. Some data files, I mean, I do appreciate that some data files are massive. So then what you could do is maybe, if you're going to store it on S3, then maybe you actually store within source control maybe some kind of log or something like that, or you version that data within S3 so that you know where you're going to come back to as well. So there's a healthy dose of pragmatism, but the principle is to make sure you've got something that's virgin of any changes, and then you apply those deltas as you apply your test cases into your application estate. Where are we now? Audit and explainability. I said I was a finance guy. See, audit. You know, it's nothing more sexy than audit on a Saturday morning. Data cataloging. Do this. So spreadsheets don't cut it. You know, there's some great tools out there, and actually some of them are open source as well. If you've got nothing, a spreadsheet is fine, but if you've got a spreadsheet, think about using, you know, things like Amundsen, Atlas, open metadata. Some of them have a kind of freemium model kind of thing. If you're using AWS data zones, it's a little bit immature. I hope there's no AWS people here. But it is a little bit immature, and the UI is a little bit clunky, but there are others out there. But ideally, you want your cataloging tool to support branches and release tags as well, so that the catalog's metadata can be altered as part of an atomic kind of release rollout, so that I change the catalog, I change the code that actually alters that data structure and alters the data within it. I've changed the data structure. All of that then gets wrapped up into something that is a deployable artifact and promoted between environments. But you can't do that unless you've kind of got either separate instances of your catalog, or you've got a way of doing kind of branches and tagging. If you've got it in a nice cataloging tool, then you can query that catalog programmatically as well, which is a nice thing to do. But it also comes into how you're going to treat data as a product, because if you treat data as a product, then people can start to self-serve. And if you've done this and it's rolled out with the data structure changes, then people can actually rely on your data products to say, actually, I know that that's what this data looks like because they've made guarantees that it doesn't get published until the catalog is updated. And actually, for additional points, I'm just looking at my notes here, track the lineage in your data as well. I'm not just talking about source saying, I've got 5 minutes and I've got 4 points to get through. I'm not just talking about data source A goes to data source B, you know, because that's kind of straightforward. There is more complex lineage than just A goes to B and goes to C, because that actually you might need to track it at a field level, or even worse, you might need to track it at a row level as well. that actually the lineage of where the row I've got today in this derived data source, where did that come from? Because especially if you're doing kind of large calculations or roll-ups and things like that, analytical applications, that piece of data that was bilge, no good up here, I want to trace that through, and I only really want to change the stuff that's dirty, that's actually needs changing. I don't want to recalculate everything because it's wasteful and you know, it means my stakeholders are going to have to wait for that stuff. Code traceability. I've never seen this done well in the wild. Code changes over time. We're really good at tracking what code has changed and labeling code and things like that and pushing it out. But if we don't tie the code that generated the data together with the data itself, we say, well, actually, this row of data, this was generated by this version of the code. When we do time travel in that, we're going to have a devil's own job actually debugging how that data came into being. So, you know, all you need is some kind of manifest somewhere, a little table that says, you know, maybe between, if you've got batches, if you're in a batch world, or maybe if you're a streaming world, maybe it's between dates. Say, well, this is the version of the code that applies to this kind of data set, and it gives you a way of coming back to that later. It also allows you to CYA with the downstream systems, and they say, well, what's wrong with this data? This report is no good. It's not me, it's these guys upstream of me. And basically, code isn't static. The code in prod now won't always be the code that generated the most recent data for a particular entity. Yeah. Consumption. So I've got 3 left. So define an API for accessing data. It doesn't, I mean, it sounds very basic when you say it like that, because you want to make the domain clear to the reader, which should also match some kind of underlying data structure as well. And you want to keep data from the inside separate from data on the outside. Data on the inside is things like job queue tables and tracking what sort of data and the metadata and the metadata in terms of maybe you're tracking the version of code that loaded that data. That's data on the inside. That's data that's private to you. Data that you publish out, that's the data that you want to curate and allow people to self-serve. Now, please, don't allow external systems directly to your data store. If you've ever worked in a bank, someone will turn around and go, oh, we could just do a database connection link right into the database. Oh, it's a great idea. It's so cheap, and you can have access to the data and things. Now, as soon as you do that, congratulations, you're now married to that people who are coming to get your data. Yeah? Now, marriage is a very fine institution. My wife tells me daily. But it's a fine institution between 2 consenting adults, you know, between 2 databases. This is a nightmare because the other system, you've allowed that other system into your database, and that could add extra load, risks of deadlock. It's difficult to audit. It's difficult to secure. And it's difficult for you to evolve your own schema because you are now married to this other system. And as you want to change your schema or your release cycle, they go, oh, no, I'm using that table. We've got a production thing that looks at that. It's, oh, well, thanks a bunch. So it's just something to be very, very aware of. 2 minutes, okay. So you get a minute apiece on the last couple. SLOs and SLAs for data. So this is a little bit borrowed from the data mesh folks. Keep yourself honest. Create SLAs for the accuracy and quality of the data, the referential integrity, the timeliness, the freshness of your data. If you ever need to restate, what will be the time window for doing so? What can your consumers tolerate for that? But you just keep yourself honest. What documentation will you provide? How will you keep that fresh? How will you keep it live? And if you're doing this automatically within your data pipelines, you can say hand on heart, I know it's up to date because it passed all my tests and it didn't get into prod until all my other automated tools had actually updated the catalog and the lineage and all of this kind of stuff. Now, my last one is to treat data as a product. Yeah, it's very much a courtesy of the data mesh crowd, but you don't have to be in a data mesh to do this. Product thinking it can be very intrinsic to whether you're in a data lake or whether you're in a data mesh. Because you want to curate that data, you want to feed and water that data and make sure that it's actually looked after, and that when you look someone in the eye, you can say hand on heart, yes, this data is good to go. It's ready to go. My docs, you can rely on them. So, and the more that you think about a product and how it evolves, and you think of the people that come and use that data, because ideally, you don't know who those people are. You know, they're coming to self-serve, and you want to actually be able to make guarantees about that. Because if you don't, unfortunately, people are going to have to speak, and we don't want that. We definitely don't want that. But the more the data's procured by others and actually used by other people, the more it's relied upon. And you folks, or a lot of you folks will be data scientists, you want to just say, I don't want to speak to someone, I want to just go and get that data and understand what it is, and there's no surprises in it. So the more that you can do that, the more derived data that we can build. You know, that 1.7 megabytes per second, yeah? The more we can create more derived data. And that means that we can become a data-driven organization as well, which I think will be close to a lot of your hearts. So a little recap. Sorry, I went a little bit fast towards the end there, but here's the 12. Happy to talk. How much time have I got? About 30 seconds, I'm guessing. Stop. But happy to take a few questions and things, or catch me outside. We can have a coffee or what have you. But thank you very much.
Hi guys, we have 5 minutes for questions, so if you want to raise your hands, I'll get through everyone.
Yeah, thanks for the presentation. And one of the slides, I think you said the data can be, rather than copying the data from production to UAT or the lower environment for any sort of testing, you said maybe we can use some utility to copy the data directly into those environments. But that data may also contain some sensitive information, and there could be data privacy concerns. And so, I mean, how that's something that maybe thought.
Thank you for reminding me. I didn't bring that up. You're absolutely right. So if you do something like that kind of the Kafka feed of data, it actually gives you a centralized point to then you could put maybe a data transformation that sits on the prod side that actually then masks some of that data, or if you're going to use something like crypto shredding as well, to actually throw away keys if you kind of need to do GDPR right to be forgotten. There's some techniques that you can do on that, but I think that the value that it brings in lower environments being kept in lockstep with prod, I think is super important. But I think you do also have to be very, as you quite rightly point out, you have to be very wary of that. And if you've got something that's running operationally, that's making sure that your PII data is masked, that's actually a lot more, you can ensure that that's happening more than just if someone takes a dump of prod data and sticks it into UAT, because then you might then say, oh, well, the DBAs, if you have a handoff to a DBA team, then you say, oh, well, did you run the anonymization scripts and things? Whereas actually, if you've got something that's kind of constantly doing that, you check it when you roll it out, make sure that the data governance folks are happy, and then you're off to the races, really.
Thanks, great talk. In terms of your consumption points there, particularly 10 and 11, but maybe 12 as well, schemas do change, and as organizations use data, hopefully the data schema changes. Is there any kind of productionalized way to transmit changes like this throughout all your kind of user base, to have those repercussions go and downwards towards the client? And I'm thinking in terms of potentially how do you renegotiate an SLA, and then also going upwards to say, well, now we need different things of you to comply with this new schema. Is there some guidance you could give us on that?
Thanks for that. That's a really tricky point. I think I run a consultancy, so the first thing they teach you in consultant school is the answer to any question is it depends. But it does depend, right? So it depends on the volumes of data that you've got. It depends on those consumers. And I think that So we're doing some work in and around kind of data mesh for an insurance company at the moment. Now, they turned around and said, this is life insurance data. This data has to be okay for the next 40 years. I was like, right, okay, we best get this right. So you then bake that into a little bit more into your data governance process, and you probably pay attention a little bit more to that. You're like, I need to get this right for 40 years, or if not, I need to come up with some kind of migration plan for that. Depending on the size of your data sets as well, maybe it's okay to have a V2, which is an exact copy, or it might be that you actually have to have you have to have something within your SLAs with them, say, well, actually, we could migrate this schema a little bit later, but they are going to be nullable fields, and that may or may not be okay for you. I don't have a silver bullet for you. I'm really sorry about that. But that is, I mean, you're right, that is super, super tricky. But it will depend on the consumers. But I think that one of the cool things about kind of data mesh as a kind of socio-technical approach is that it's starting to surface those things, and you have those conversations a lot earlier, rather than someone coming to you and kind of going, oh, well, I want this. You go, oh, well, actually, I'll schedule that sometimes in the next 3 to 6 months. You're at least having those conversations a lot earlier, and the earlier you have those conversations, the cheaper they are as well, yeah? But it's... I wish I did have a silver bullet for that. But then I wouldn't sell any consultancy as well, so... Thank you.
Guys, it's 12:30. I think we should break for lunch, unless someone has a really quick question. Literally like 1 minute. Otherwise, need to get my script. Yeah. So yeah, we'll be pausing for lunch now. If you're looking for vegan, vegetarian, or gluten-free options, please head to the lunch bar opposite the Code Node bar. All other options are available at the other 2 stations. The beer kegs, kindly sponsored by Sheridan's, are now open, so grab your free pint and get your booklet stamped. If you can give another round of applause to James.
Thank you.